No. All right. Number 1, part A is 0. Part B is the fact that the crate's at rest. It's not accelerating. In number 2, part A is equal to. Part B is 0. Number 3, part A is equal to. Part B is 0. Part C is equal to. Number 4, A is greater than. B is right. Number 5 is 150 newtons. Number 6 is 200 newtons. Number 7 is 250 newtons. Any questions on page 22? What? Number 7, it says that we have constant velocity, so forces have to balance. So if I were to look at this picture, P and F have to be the same value. Constant velocity, balanced forces. This really wasn't an assignment on friction. It was an assignment on balance versus unbalanced force. Okay, any other questions on that page, Kiara?
Why is 4B?
Okay, because it tells us that P is larger than F, so that means it's accelerating to the right, so that force has to be bigger than that. Therefore, the net force and the acceleration are always in the same direction. That's what we talked about with unbalanced force. Unbalanced force and acceleration are always in the same direction. Anything else? Okay, let's now look at the calculation page, page 23. Number 1, your final answer should be 210 newtons. Number 2, your final answer should be 0.799. And number 3, your final answer should be 51.9 kilograms. You want to go over any of those 3? Yeah? Number 2. Okay, so let's take a look at what it says. It says that we have a constant velocity, so that means forces are going to balance. And it tells us that the force that's being exerted, that's our applied force, is 2,350 newtons. We have a mass being given to us. I want you to find the coefficient of kinetic friction. The first thing I'm going to do is I'm going to start by making a free body diagram. So that way I can see what's balancing what. So I'd have an applied force in one direction, a force of kinetic friction in the other direction, the weight of that sled with the coach on it pulling it down, and the normal force pulling it up. I know those are going to balance, and these are going to balance. And I know that this force is 2,350 newtons, which means that force of kinetic friction is also 2,350 newtons. Now, the other things I know are the mass, which is 300 kilograms, and I am asking you to find the mu K value. In this problem, we don't know what the materials in contact are, so you can't go to page 1 of your reference table and just look that up. You're going to have to calculate it by using the equation FF is mu Fn, so mu is FF over Fn. But at that moment, you should be realizing, wait a second, I can't plug into that yet because I don't know what Fn is. But I do know that Fn is balancing Fg. I don't have Fg yet, but I can get it because I have another equation on my reference table that enables me to find the weight of something if I know the mass. And that equation is G equals Fg over m. So Fg is mg. That means I'm going to take 300 kilograms and multiply by 9.81 meter per second squared. That means the weight of this sled with the coach on it is 2,940 newtons with the 3 sig figs. I'm now going to put that here, which means the normal force is also 2,940 newtons because those two forces are balancing. Now I can go ahead and plug into my coefficient of friction equation by taking 2,350 newtons and dividing by 2,940 newtons. The newtons are going to cancel, which leaves me an answer with 3 sig figs of 0.799. Okay. Anything else? Khalees? Yep. So in number 1, it tells us that we have this crate sliding across the floor. So let me start with a free body diagram of the crate. There is the crate. I know its weight is pulling it down. The floor is going to push it back up. And it doesn't tell us whether we're pushing on it or not. So let's just say it's moving this way, which means the force of kinetic friction would be this way. What do I know in this problem? I know those two forces have to balance out because it doesn't accelerate up or down. I know the mass of this crate is 28.6 kilograms, and I know the coefficient of kinetic friction is 0.750. I'm asking you to find that force of kinetic friction. To do that, we use FF is mu Fn. Well, I have the mu, but I don't know the Fn yet. But I do know that Fn balances Fg. I don't know Fg yet, but I do know the mass. So I can get Fg by using G equals Fg over m. So Fg is mg. That is 28.6 kilograms times 9.81 meter per second squared, which means that the weight of that crate is 281 newtons. So that's 281 newtons, and the normal force, which is balancing it, is 281 newtons. Now I have everything I need to solve for that friction force by plugging in 0.750 times the 281 newtons. And when I work that out, I find that that value is 210 point newtons with the 3 significant digits. 0.750, not 0.75. You copied it down incorrectly.
210.75.
Yeah. All right. So let me do it on the calculator and I'll show you what you see. So 0.750 times 281. Because that next digit is a 7, we have to round it up to 211. So that is my mistake, 211. Newtons. Okay. Anything else? All right, let's take our quiz. You can use that assignment. You can use your reference table. You can use your calculator. Please make sure your name's on top of the quiz. When you finish it, just turn it over. You do not have unlimited time to do this. So keep your eye, or keep focused, get it done. No dilly-dallying. You're welcome. Make sure you read the directions at the top of the page. You're welcome. You're welcome. When you're done, please just turn it over. One more minute. All right, let's make sure your name is on top of that quiz and let's pass it in. Whether you're done or not, your time is up. So let's pass it in. Make sure your name's on. Let's pass it in. Time is up. That means you have to put your pencil down. Pass it in. Kara, pass it in, please. And then let's take out your notebook. All righty. Let's start Newton's second law today. This is our second to last section of the unit, so we will be finishing it this week. Test early next week, okay? The other reminder, there is no written assignment tonight except to work on your test corrections. And as I mentioned a little while ago, the quarter interim period ends this week. So if you owe me anything this week, like quizzes, labs, they got to be done this week in order for me to update your grade appropriately. I will be after school today and Wednesday of this week. I may also be here Thursday. But I would not suggest waiting until Thursday if you want to make any of that stuff up. Okay. Get it done sooner rather than later. So that way I'm not on your case by the end of the week, because by the end of the week, I'm going to become pretty annoying if you owe me work, especially stuff that's owed more than 2-3 weeks. That's not going to happen moving forward. You're going to get one. If you're out one day, you get one day to make it up. If you're out 2 days, you have 2 days to make it up. That includes labs, and I'll just give you a 0 for a lab and mark you as a failing grade for the quarter. That's it. And then you can make it up by June. But I'm not going to chase you down for work. You got to start taking responsibility for your absences and getting things made up accordingly. All right, let's start section G, Newton's second law. Newton's second law. Now, what are we going to ask you to do when you eventually take your quiz on this Thursday this week? Obviously, you need to know what is meant by force. The entire course now is about forces. You have to be able to differentiate between situations where you have a balanced force versus where you have an unbalanced force. You'll need to determine what a net force is, which you should already be able to do. You should be able to state Newton's second law and then explain what it means and then solve problems with it. And we're going to spend 3 class periods on Newton's second law. There's a lot to it, a lot to the problem solving, and then we actually do 2 labs related to their applications. In order to solve problems with Newton's second law, you have to be able to draw free body diagrams. So that's also going to be part of what I'm quizzing you on here. So to quickly review what we mean by a force, remember it's all pushes and pulls. Every force starts with a capital F, and then we add a subscript after it to tell us which type of force. They're all measured in newtons, which is abbreviated as a capital N. It's a derived unit that's equivalent to the units of mass times the units of acceleration, a kilogram meter per second squared in the metric system, and they're vectors. So that's why we're drawing them with arrows going in the proper direction. Now, what does Newton's second law state? It says that the acceleration of an object as produced by a net force is directly proportional to the magnitude of the net force. It's in the same direction as the net force, and it's inversely proportional to the mass of the object. Again, it states that the acceleration of an object as produced by a net force is directly proportional to the magnitude of the net force. It's in the same direction as the net force, and it's inversely proportional to the mass of the object. Now, in middle school, you probably learned that Newton's second law says that when there's an unbalanced force, an object will accelerate. And that is true. That is what this law is stating. But at the high school level, we expect you to be able to talk about what that acceleration is dependent on in terms of the mass of the object and the net force. And the way it's written here at a more complicated, more sophisticated level is it tells you how that acceleration relates to net force and mass. It gives you these proportionalities, which means we're going to be able to create an equation and draw graphs and talk about if I double something, what does that do to the acceleration? If I triple something, what does that do to the acceleration? And so forth, based upon the proportionalities in that statement. So I have this little here because if you're reading that and you don't break it down into small chunks, it gets to be a little complicated, or it sounds complicated, and it really isn't. So let's break it down into small pieces, okay? Is everybody all set with that bullet item? Okay, so let's now try to explain what it says. It says, first of all, that this law, when you read it, applies when the forces are unbalanced. Newton's first law tells us what happens when the forces are balanced. This law tells us what the object will do when they are unbalanced. Okay, so first law is balanced, second law is unbalanced. And it tells us that the acceleration depends on 2 things. First of all, it depends on how much net or unbalanced force there is, and that is a direct relationship. which means that if I double the net force, the acceleration would double. If I quarter the net force, the acceleration would be quartered. Whatever we do to the net force is also going to happen to the acceleration. That is a direct relationship. But it also tells us that the acceleration depends on how much mass or inertia the object has. And that's an inverse relationship. And what that would mean is if I double the mass only, the inverse of that, inverse of doubling, is halving. So if I were to double an object's mass, it would halve their acceleration. Now from that, it means we can construct two graphs that relate acceleration to net force and to mass. So let's look at what these graphs are going to look like. I'm going to skip over to my document camera for that. So let's look at what these two graphs look like. It says that the acceleration is directly related to the net force. This would be the graph of the acceleration versus the net force. Here we see a direct relationship. So what does that mean? It means that if the net force is multiplied by 2, the acceleration would also get multiplied by 2. That's direct. You see how the factor, that the changing factor, is the same. It would mean that if our net force is a quarter of its original value, that means multiplied by a fourth, what would happen to the acceleration? If the net force is multiplied by a fourth, what's going to happen to the acceleration? That's right. It's also multiplied by 1/4. That's a direct relationship. Whatever we do to the net force will also happen to the acceleration. The second relationship that's described is the one between the acceleration and the mass of the object. And this relationship is an inverse one. Inverse relationships are hyperbolas. So let's talk about what that means. It means if the mass is multiplied by a factor of 2, then the acceleration is not multiplied by 2, it's multiplied by the inverse of 2. What is the inverse of 2? A half. It means that if the mass is multiplied by a fourth, then the acceleration would be multiplied by what? What's the inverse of a fourth? 4. We would get 4 times the acceleration. Okay, so I'm trying to give you some ideas of what a direct relationship means and what an inverse relationship means, because you're going to be asked, if I double this or have that or quarter this or triple that, blah, 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 what happens to the acceleration? And you have to use your understanding of the relationships to help you figure that out. So again, to explain this in a little more detail, as we said, this law is talking about the forces being unbalanced, producing an acceleration directly with the net force and inversely with the mass. So that means if the net force goes up, so will the acceleration in a direct way. And it means that if the mass goes up, the acceleration goes down in an inverse way. That's what we mean by direct and inverse. All right, can I go on? I'm not seeing any no's. All right, so let's now talk about what that means as an equation. Those relationships that we just described lead us to the equation for Newton's second law, which is A equals F net divided by M. Now let's go to page 6 of your reference table and let's check that off. That's right here on your reference table. A equals F net divided by M. This equation is called Newton's second law. It's the first equation we're going to learn this year that has a name that goes with it. A equals F net divided by M. We've already checked off the variable A. It stands for acceleration. We've already checked off the variable F net. That stands for the net force. We've already checked off the variable lowercase m, the mass in kilograms. So that's the equation for Newton's second law. We've already said the A in that equation is our acceleration in meter per second squared. F net is the net force measured in newtons, and m is the mass of the object measured in kilograms. Now remember, a newton is a derived unit, a kilogram times a meter per second squared. So if I were to change out this net force value from newtons to kilogram meter per second squared, and the mass is in kilograms, then the kilograms will cancel out, leaving us with the unit of acceleration, which is meter per second squared. So that would be the dimensional analysis applied to that particular equation. Okay? Any questions? All right, then let's go to page 24 in your packet and let's start working on the problems associated with Newton's second law. Number 1, what acceleration will result when a 12 Newton net force is applied to a 3.0 kilogram object? And then what will be the acceleration if I apply it to a 6.0 kilogram object? Basically, this question has 2 parts. So let's break this down into 2 parts. Let's start with our first part using our guess method. The given values are 12 newtons, which we are told is a net force, F net, and 3.0 kilograms, which is a mass, M. The unknown is the variable A, lowercase a. What equation do we use? Newton's second law. A equals F net divided by M. It's already solved for A, so let's go ahead and do our substitution with units. So A would be 12 newtons divided by 3.0 kilograms. So when we solve that, 12 divided by 3 is 4. So with 2 sig figs, we would get 4.0 meter per second squared. Now, I am not going to use the guess method for the second question. I'm going to use the mathematical relationships that I know from Newton's second law to help me figure out what happens when I change the mass from 3 kilograms to 6 kilograms. What multiplication factor gets me from 3 to 6? 2. I'm multiplying by 2. So the mass is being multiplied by 2. If I double the mass, according to Newton's second law, what happens to the acceleration? It's what? Which relationship is it? Direct or inverse? Inverse. So what is the inverse of multiplying by 2? Multiplying by a half. That means the acceleration is multiplied by a half. So here's the original acceleration. We have to multiply that by a half. So what's my new acceleration? Ryder? That is correct. And that's how we figure that out. We don't have to go through the guess method because we know the mathematical relationships. Now, how can I figure out that mathematical relationship without memorizing it? Because I really don't like memorizing things. I don't know about you. I don't want to have to memorize. Look at the equation for Newton's second law. And you can add this to your notes because you still have your notebook out. Do you see how the mass is in the denominator of the fraction? When the variables are positioned this way, where one is on the left side and the other is in the denominator, that relationship is said to be inverse. Whereas if I have them positioned like this, where one variable is in the numerator and the other's on the other side, that is called a direct relationship when they're set up that way. Okay, so whenever I position them this way, that's the inverse, showing the inverse relation. Whenever they're positioned this way, that's how we see there's a direct relation. Okay, so that way you don't have to kind of memorize every single relationship. The reference table is full of them. But if you understand where variables are positioned in equations, what that will do, then you can figure out the relationships for any equation I give you. Let's now look at question 2. In number 2, we have a net force of 16 newtons causing a mass to accelerate at 5.0 meter per second squared. I want us to determine the mass. Janicia, can you give me a given, please, for this question? Equals what? Good. F net is 16 newtons. Ryder, what's my other given? So little a is 5.0 meter per second squared. What is my unknown variable, Gavin? Little m. All right, what equation from the reference table, Haley, should I start with? That is correct. Now this is not solved for mass. It's solved for a. You have to move it around. I'll give you a minute to do the math on that to solve it for the variable m. What's that equation going to look like when you move it around to solve it for m? Who can tell me? Flavia, you have it? Okay, and so what does it solve for m? No. What does m equal? Gianna? F net divided by a. Let's go over how we get that. If we have the equation a equals F net divided by m, the first thing we have to do to get m by itself is we have to multiply both sides by it. Otherwise, you can't solve. So ma is F net. Now you want m by itself, which means you have to undo the multiplication that's here by dividing both sides by a. So m is F net divided by a. That's the algebraic manipulation step. Okay, so there's the equation for m. Now let's go ahead and do our substitution with units. So m would be 16 newtons divided by 5.0 meter per second squared. Now you're going to solve that with an answer that has proper units and sig figs. Blake, can you tell me what that means the mass is? No, newtons is force. All masses are measured in kilograms, kg. That is correct. All right, number 3. We have an object that is accelerating at 2.0 meter per second squared. Now the net force is going to be tripled and the mass is going to be doubled. What's the new acceleration? All right, this is all mathematical relationships. We don't solve it using the guess method. I need you to think about what the relationships are between net force and acceleration and mass and acceleration. Let me show you how to set this up. They're telling us that the net force is tripled. Shelley, if I triple something, what am I multiplying by? 3. All right. And Khalees, if I am doubling something, what am I multiplying by? Okay. Now let's think about the equation. A is F net over M. Max, what's the relationship between A and F net? Direct. That means A is also going to be multiplied by 3 because there is a direct relationship between F net and A. Elisa, what's the relationship between the mass and the acceleration? Inverse, that's right. So that means the acceleration is not multiplied by 2 because of this change. It's multiplied by a half. That's an inverse relation. So what we have to do is multiply the original acceleration, 2.0 meter per second squared, by each of these changes. First, we're going to multiply it by 3, and then we're going to multiply it by a half. So what does that mean the acceleration is, Chaudhry? What's 2 times 3? 6 times a half. Half of 6, 3. So the acceleration is therefore 3.0 meter per second squared. We do it all using relationships. And that's how question 4 is to be done as well. We start off with an acceleration of 2.0 meter per second squared. The net force is going to be tripled, and the mass is going to be halved. What's the new acceleration? So here, we're telling you that the net force is multiplied by what factor, Devin? 3. And Nikolai, what is the mass being multiplied by? Okay. So if the net force is multiplied by 3, Alex, what's that going to do to the acceleration? Multiply by 3. And Jacob, if the mass is being multiplied by a half, what does that mean happens to the acceleration? Multiplied by 2. So let's take our original value. Let's multiply by 3 and then by 2. 2 times 3 is 6 times 2? 12. So 12 meter per second squared for that acceleration. If you need a pass to your next class, just let me know. I'll write it for you. Otherwise, have a great day. We'll pick up with more of this tomorrow.